Assalamualaikum and a very good day. So today I will talk about our project signal on part B, which is question 3. So here we get an ideal phase high pass filter that has frequency response function in frequency domain, which is 6 exponential negative j to omega, and with an heavy side function where omega more than 3 and omega less than negative 3. So, on the first question, it tells us to find the impulse response ht. As we know, this frequency response is in frequency domain. So, to get the impulse response which are in time domain, we need to inverse Fourier transform this frequency response function. So, in the MATLAB, we will get this coding. What it will do is, first of all, it will have of the function of the heaviside function, which then times with the h omega, which is the frequency response function, and then after that we just simplify and inverse Fourier transform the frequency response function to get the ht. So after that we will print the value of the impulse response of the ht and then display the plotting of the ht. So what we will get on the output is the impulse response of ht, which is 6 delta t minus 2 minus 6 sine 3t minus 6 over pi t minus 2. So this is the graph that we get from the MATLAB. That is for the question number 1. So question number 2, it tells us that it wants the output of the yt when the input xt is given by xt sinc 5t over pi. So what we need to do here is, like before, we provide the function, all the function that we have until ht, and then in addition to that we need the function xt to be times with the function ht, because the resultant of yt is equal to xt times with ht. So what we get here, first of all, we, as usual, we need to inverse Fourier transform the h of the frequency response to get the time domain function, and then the time domain function we need to get the, oh, sorry, my bad. So this one is actually no need for it, because what actually happen is, we want, first of all, we want the frequency response of the frequency response in frequency domain of the yt first, which will result in h omega times with x omega. So what we need to do here is we need to Fourier transform the xt function to become xt in frequency domain. So after we Fourier transform this xt, we just simply times it with the frequency response, and then after that we will get, to get the yt, we just inverse Fourier transform the y omega, which is the y in frequency domain. So after that, like before, we need to print the result of the yt and then display it and plot it into a graph. So this is the plotting for the xt and this is the plotting for the yt. So the output response we will get this, and for the graph for the xt, because it is a sinc, so it will become like this, and after we times it with the ht, which is the impulse response, we will get this, which are the result of ht times with xt. So for the last question, which include a new input xt, which is a periodic signal. So if we have a periodic signal, we need to use the Fourier series. Here we need to define the Fourier coefficient of the Fourier series of the pulses of the periodic signal. So we will have Bn, An, and N0. So this we search it manually and then we will get this value. So we define T, which are the distance, the width of the pulses to 2, and omega naught as 2 pi t, 2 pi over t. So we sample it to make it smaller. We want to have just some value, so we need to sample it. And then we define n as 100. So here there are x frequent I k, where we need to times the an and bn value with cos k omega naught ti. These are the actually the formula of the Fourier series, the summation of Fourier series actually. So after that we need to plus it with a naught, so we get the full Fourier series equation. So after that, this is only for the periodic signal. So we actually need to find the yt, which are the result of ht times with xt. So for that, we need to time this function with ht. So ht, we make it into, first we define is it in frequency domain, and then like I said, we times it with an, which are the an value for the periodic signal, times it with the h value ht, and then same as the Fourier series formula, we times it with cos k omega naught ti, and then plus with the angle of the ht, and then same as for the b, and then at last we sum it with the a naught value after we times with h naught, and then like before, the summation of it. So after that we just plot it with this coding, and then we will get, first of all, for the Fourier series approximation with only the periodic signal Fourier series, we will get this. And then after we times it with the ht, which resulting in yt, we will get this. So we can see the difference in the amplitude, and also the actually the y is the same, only the increase in amplitude. So that's all for today. Thank you.